Alright, so let's try this again. We got video 3.2, unit 3 on the periodic table. In this one, we don't have any specific notes to write down. Yay, go me, yay! I know you're so excited about that, but don't be so excited because in the next unit you have to write some notes down. In this one, what I did, I took some blank copies of the periodic table, and basically I'm just going to talk you through it. In the last video, we talked a little bit about how it was set up. We talked about periods, we talked about groups, we talked a little bit about metals, because we named the alkali metals, the alkali earth metals, the transition metals, boron, carbon, nitrogen, and oxygen group, fluorine, which starts the halogens over here, and then we had the noble gases. So that stuff is all covered in video 3.1. In this video, I want to just point out a couple things. I want to talk about where we find the metals, where we find the metalloids, and where we find the nonmetals. I'm going to point out where we have the solids, the liquids, and the gases on the periodic table. We're going to make note of the diatomic elements on the periodic table. And we'll just label the lanthanide and actinide as we go along. Alright, so before we begin, let's start by labeling the metals. The metals on the periodic table, I'm going to write in red, are located on the left-hand side. So everything that's over here, and what I left side, I mean left of this funky staircase. Okay, so you see a funky staircase there. It's kind of in a black bold line. Anything to the left of that staircase is considered a metal, except for hydrogen. Hydrogen is not a metal. Hydrogen is a non-metal. It just happens to be over there because it has one valence electron. And all of the elements in group 1 there have one valence electron. But hydrogen is not a metal. Then we have on the other side the non-metals. You're going to, in class, be coloring a periodic table and having to label these things. So if you want to label them on your regular periodic table, go ahead and make a little note of that so that you have it. There are definitely more metals than there are non-metals on the periodic table. Metals have specific properties like malleable. They're malleable. I was going to say malleability, but malleable means they can be hammered with a mallet and they can be pounded into these very thin sheets. They are ductile. You can use them to make a wire out of. They conduct electricity. You don't want to stick a metal object into an electric socket. You're going to get yourself all zapped, okay? Metals conduct electricity. Metals conduct heat. So they have luster. They're very, very shiny. You might say to yourself, lithium is a metal, sodium is a metal. This doesn't make any sense to me. But elemental lithium, elemental sodium, elemental potassium, those elements are metals. Okay, don't think sodium chloride. Sodium chloride is a compound, 2 or more elements chemically combined. Sodium metal is a very soft metal. You can actually cut it. It bends very easily. Think of aluminum. Okay, here's aluminum right here. Aluminum is a metal. Okay, we want to get rid of that. Ooh, go away, go away, go away. It won't go away. Alright, now, nonmetals have unique properties as well. Nonmetals are brittle. They lack luster, which means they're not shiny. Sometimes you'll use the word dull. They have, they do not conduct heat. They do not conduct electricity. They break, they shatter into a million little pieces. Okay, so they have the opposite properties of the metals that are on the left side. Now, there's a region. I wish I could make this thing disappear. Hold on a second. Let me see if I can get it. Let me pause you. Alright, everything went away, so I'll just go with the flow here. Alright, we've got this staircase again. There's a region in between the metals, which were over here, and the nonmetals. I'll abbreviate NM for nonmetals. And those are called the metalloids. Metalloids include boron, silicon and germanium, acetine and antimony, tellurium and polonium, sometimes not, astatine. Okay, so the ones that are right on the staircase, not aluminum, and sometimes you'll see polonium, but I would say no. So all of these guys right here are called metalloids. Metalloids are elements that have properties of both metals and nonmetals. You probably should write that down in your interactive notebook. I'll flash it on the screen. Okay, so we conquered metals, we conquered nonmetals, we conquered metalloids. Now let's go to another periodic table, and let's make it a little bit bigger. 99% of your periodic table at STP, for those of you who still don't know what STP is, it stands for standard temperature and pressure, are solids. Okay, so I'm going to leave those for last. There are two liquids at STP. They are bromine and mercury. Bromine happens to be a nonmetal, so it's a liquid at standard temperature and pressure, and it's a nonmetal. And mercury, which is number 80, I put an X on top of it, is a metal that is a liquid at standard temperature. If you've ever seen liquid mercury, it's kind of cool. In the Terminator, they had an episode where they took the idea of liquid mercury and, I don't know, made some monster come alive with it. Who knows? Okay, so those are our metals. We have gases. I'm going to make the gases green. Gas green. And there are a bunch of gases on your periodic table that you have to know. They're nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton, xenon, radon, and hydrogen. So all of these suckers over here with the green X's over them, those are your gases at STP. Everything else on the periodic table is a solid, and I'm not going to X them all out. Just everything else is a solid at STP. So I brought up another blank periodic table, and I want to mark one more thing for you on here so that everybody is sure that they know them. I've said it almost from day one. There are the diatomic elements on the periodic table. You need to know what those are, and you probably at this point have committed them to memory. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Really bad writing, and I apologize for that. Someday I'll get a better way of writing that stuff down. But they are here. Let's see, what color should we make them? Let's make them purple. Okay. Nitrogen is atomic number 7. So there's 7 diatomic elements. We're going to start with atomic number 7, and we're going to make the shape of a 7. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So there's your 7, but that only includes 6 of them. The one that is left out is the hydrogen, which is right here. So you have to remember that there's one more, and that guy over there is diatomic as well. So you're going to have those committed to memory in order to make your life much, much easier. I like that purple pen. Kind of cool. Okay, good. That was a nice short video. Just kind of went over some basic things on reading the periodic table. Hopefully that helped you out a little bit. Until next time.